Hello, and welcome to Grade 2, Unit 11, Perimeter. I'm Shanna Uwe. So for your first task, you're going to pause the video and complete the task either by yourself or with a team or partner. So solve for the answer and record an equation to prove your answer. As you're working through the task, think about what is important understanding that a student would need to know to have success with this task, and what should instruction look like so whenever they're given a task like this, they're successful. So once again, pause the video and take some time to solve that. So let's look at the progression of perimeter benchmarks with BEST. In first grade, they estimated the length of an object to the nearest inch, measured the length of an object to the nearest inch or centimeter, and identified, compared, and sorted 2- and 3-dimensional figures based on defining attributes, which is especially important whenever we're dealing with triangles, rectangles, and squares for second grade. In second grade, we're exploring those attributes by placing unit segments along the boundary of those figures without gaps or overlaps. We're also finding the perimeter of a polygon when we're given whole number side lengths by counting those unit segments or adding them. And then we're also representing perimeter with a number and appropriate units. In third grade, we're solving real-world math problems involving perimeter and area of rectangles with whole number side lengths using those models that we'll explore in second grade, and also moving to a formula. And we're also solve real-world math problems involving the perimeter and area of composite figures, which are composed of non-overlapping rectangles with whole number side lengths. For this video, we're going to focus on those second grade perimeter benchmarks. In second grade, it's the first time ever students are learning about perimeter, so we need to start with understanding of what perimeter is. We need them to explore and understand it and connect it to real-world scenarios from when they may find the perimeter figures. And also, it includes hands-on experiences and exploration using tools. So here's some just examples. They may measure figures such as rectangles, triangles, pentagons, squares, and find the length of each side and then combine them to find the total perimeter or distance around a figure. They might use square tiles like in the middle example, create a rectangle, and then determine what the side lengths are of each figure. And you can see another example above that. Or even geoboards where we're creating different figures but then taking it the next step and finding that perimeter. In order to truly understand what perimeter is, we need to have some real-world scenarios. So they need to understand perimeter could represent a fence around a garden or a house, amount of wood for a frame of a picture, distance I ran around a track, placing a border around something, and placing trim around a mirror. So those are just some examples, but you want to make sure kids are exploring, doing a scavenger hunt, and looking for other examples of what perimeter could be. So now that students have kind of explored a little bit and found that perimeter is the distance around something and they understand that, they need to continue that understanding that they are also doing it with a specified unit or object to find the perimeter. In order to find that perimeter, you're placing that same object with the same length without gaps or overlaps around the outside of the figure. And then we're either counting or finding how many in each side and adding those totals for each side. So once again, remember that's only represented right now in second grade with triangles, rectangles, squares, and pentagons, and also only including whole side lengths. So for this one, the unit we're using to measure is paper clips. And so you can see there's 3 paper clips on either side, and I'm using that attribute of rectangles where I know those side lengths are the same, and then finding the other side lengths, 5 and 5. So in order to find it, I could either go through and count each and every paper clip all the way around, or I could add 3 plus 3, or I could double 3 and then double 5 to find that the total answer is 16. What unit? Paper clips. So I got to include that unit. So students can also find the perimeter of pictorial representations of the same shapes that we discussed. They can find that perimeter by counting units. So here I'm counting 1, 2, 3. Got to include that corner. 4, 5, 6, 7, 8, 9, and 10. So I need to understand that the perimeter is 10 units. Or beware of those corners. Many times students will count both sides of the corners as one. So like right here, they might count 11 and 12 as just 11. So making sure that they understand I'm counting the side lengths, not the squares in the middle. That's area. Students can also find the perimeter by measuring in second grade. So we want to make sure they're given those opportunities to do that so that they know those numbers, where they're coming from, and that they understand they're not just made up. They actually represent the length of each of those sides. So, and it also helps students understand how to find the total perimeter. So if the task was use the centimeter side of your ruler to find the perimeter of the rectangle, what might they do? Well, they're going to start by measuring the length, 11 centimeters. The width is 8 centimeters. Using what I know about the rectangle, I know if there's one 8, there's going to be 2 of them. And if there's one 11 centimeter side, there's going to be 2 of them. So now the total perimeter is 38 what? 38 centimeters. So once students have a solid understanding of what perimeter is, they've done a lot of exploration, they understand some of those strategies of counting, they should also be able to understand where those numbers come from. Then they're ready to move into being presented with figures that have all or some of the side lengths presented, like in the example shown below. You can see I understand 5 inches is the length, 4 inches is the width. Well, if the width is 4 inches, I know there's another side that also has a width of 4 inches and so forth. And then you can see that I'm also measuring and finding the perimeter of triangles and pentagons and squares, and you can see all those shapes have the same side lengths. So using what I know about attributes of rectangles and squares, that can help me to find the total perimeter of the figures. So just to kind of recap some of the strategies we discussed, using paper clips to find the perimeter, using square tiles, measuring the length to find perimeter, could be some concrete thinking. Then we're moving to representational, where I might be counting and drawing those ticks as I'm counting, or I'm actually just using a representation with those lengths filled in, and I'm going to find the perimeter from there. And then I'm moving to that abstract thinking where I'm recording equations to show my thinking and what I'm doing with the numbers to find the total perimeter. And labeling the unit, it's not just 18 as the perimeter, it's 18 inches of framing material. Remember, in order to make those bridges strong, we have to move fluidly back and forth with them to make connections between the concrete, the representational, and the abstract. Joining me today. I hope you got a lot out of second grade perimeter Math Dive in 5. We hope to see you next time.